As you previously heard, databases are the staple of business computing. Originally, that is pre-1970, information electronically was stored in flat files. This means that data was maintained in one long text file called a tab delimited file, a means of separating the fields in a record. Each entry in the tab delimited file is separated by a special character, such as a vertical bar. Each entry contains multiple pieces of information, fields, about a particular object or person that are grouped together as a record. The text file makes it difficult to search for specific information or to create reports that include only certain fields from each record. Let us look at an example of a multinational operation of their personnel file that contains records of thousands of employees. You can see that we would have to search sequentially through the entire file to gather related information, such as a name or a monthly salary. And there are a number of other problems associated with this flat file. Let me run through just a few scenarios. If you wanted to search for a specific name, and it was at, say, the end of the file, you would have to sequentially go through every record in the file before you reach the end of the file, which would take an enormous amount of time. Say also you wanted to make a change to a particular record in the file. Again, you would have to search for this particular record by sequentially going through each one of the files, or even a deletion would require the same sequential steps. Now, if you have only 3 records, as what appears in the file seen on the screen, perhaps you could do this quickly or even by hand. But if you had to search this electronically, it would take an immense amount of resources and time to find each one of the records that you are searching. This problem is not trivial and represents a serious logistic problem. Researchers sought the answers, that is, again, prior to 1970. The solution was derived by E.F. Codd through a mathematical algorithm. Briefly, he created a relational model of data. Relational databases use tables to store information. The standard fields and records are represented as columns, i.e. fields, and rows, i.e. records, in a table. With a relational database, you can quickly compare information because of the arrangement of data in columns. The relational data model takes advantage of this uniformity to build complete new tables out of required information from existing tables. In other words, it uses the relationships of similar data to increase the speed and versatility of the database. So why do we use this complicated term? The relational part of the name actually comes from the mathematics that solve the problem of flat files. The theory that Codd proposed was steeped in relational algebra and relational calculus. Fortunately, we will avoid the math part and concentrate on the business practical aspects of relational databases. A typical relational database has somewhere between 10 to more than 1,000 tables. Each table contains a column or columns that other tables can key in on to gather information from that table. By storing this information in separate tables, the database can create a single small table with the locations that then can be used for a variety of purposes by other tables in the database. A typical large database, such as the one used by Amazon, would have hundreds or thousands of tables, all used together to quickly find the exact information needed at a given time. Other solutions have been presented, including hierarchical, network, and object-oriented databases, but by far Codd's relational database model is the most popular.